So yesterday we have discussed the importance of human comfort and what all air conditioning steps you're going to take to bring about human comfort. Uh, we discussed the various parameters which affect human comfort, and we had also discussed what the human comfort chart is. Okay, we had extensively discussed the cooling loads which need to be evaluated and why rule of thumb is not really a good option when you're designing or when you're purchasing an AC. Okay. We also discussed what is cooling load, why to estimate the cooling load, and what happens if we don't calculate the cooling load correctly. We discussed the components of cooling load, which are the sensible heat gain and the latent heat gain. I'll just briefly go through what all is there in the sensible heat gain. Basically, the heat that flows into the building by conduction through walls, floors, doors, windows, etc. The heat that is directly being received as in the form of solar radiation, the heat that is given away by the lights, the motors, and the equipment that is there inside a room, the heat that is liberated, the occupants, the infiltration heat, that is the air that infiltrates through door openings and cracks or openings in windows, and the heat gain in the ducts that carry conditioned air. That was the sensible heat gain. The latent heat gain means addition of water vapor into the air. Okay, so the latent heat gain is maybe because of these factors, such as the heat gain due to moisture from outside air entering by infiltration, the heat gain due to perspiration of moisture from occupants, and the heat gain due to condensation of moisture from process in specific to be a cooking process. Okay. Uh, so we had discussed the factors with respect to the building through which heat gain occurs. We had discussed the differences between the space heat gain and the cooling load. So space heat gain is nothing but the instantaneous heat gain that takes place, and space cooling load is the uh, total heat that enters over a period of time because of the heat storage effects. And we had also discussed with the help of an example of the temple walls, which are very thick and uh, they don't really transmit the heat too much because the construction is very heavy, the walls are fairly thick, so the heat gain is very much less as compared to your normal buildings. So we had discussed also about the system design based on the outdoor design conditions. Uh, and we had come to a conclusion that around 2.5% design condition is used for comfort air conditioning. 2.5% means only 2.5% of the time in the year the outdoor temperature will be above the design condition. Okay. These terms that you need to be very much sure of before you proceed for the numericals. That is the sensible heat factor, room sensible heat factor, the grand sensible heat factor, and the corresponding lines, how to plot them on a psychrometric chart. Okay, so RSHF line will always pass through the room design condition because it represents the cooling and dehumidification process at the room design condition. Next is the GSHF line. This includes the outside air heat loads as well. So wherever you've got mixing of air with the room air or the recirculation of air with the room air, from that point the GSHF line is going to pass through. Okay, when the bypass factor is greater than 0, then GSHF and RSHF line will intersect. Okay, and that point of intersection is the supply condition of air to the room. Okay, and we had solved a small numerical just to bring you uh, in the comfort zone of estimating these cooling loads. Today we'll be solving this numerical. I want everyone to note down this numerical and be ready with your psychrometric charts. So please note down this numerical and let me know you have finished noting down. Please note this is the actual type of numerical that can appear in the exam. This is a full-fledged
Done.
has everyone noted down the numerical?
No, sir.
Okay, yeah, we are waiting. So are you accessing these video lectures through your mobiles or laptops?
Laptop.
Mobile. Mobile.
Please, if possible, use a
Mobile.
laptop because
No.
in the mobile the screen is fairly small.
So we can zoom in and see.
Okay, okay. You finished noting down?
Yes, sir.
Okay. So we'll just go through the question. The outdoor design conditions are given. 34 dBT and 28 WBT. The indoor design conditions are 24 dBT, 50% RH. Solar heat gain is given. Latent heat gain per occupant is given. Sensible heat gain per occupant is given. The number of occupants are given. Lighting load 2300 watts. Sensible heat load from other sources is given, and infiltration load, the infiltration flow rate is given. And it is said that we'll assume 40% fresh air and 60% recirculated air is passing through the evaporator coil. This means that uh, 40% outside air is getting mixed with the indoor air, and the bypass factor of the cooling coil is also given. You have to find the dew point temperature of coil and the capacity of the whole plant. So first you need to draw this diagram over here. This diagram over here. Okay. This shows the layout of your plant. Okay. Here you need to note that mixing is first taking place. Okay. Mixing of outside air and the room air is first taking place, and then that mixture is sent to the cooling coil. Okay. And then after cooling, the air is sent to the room to absorb the heats inside the room. So first you need to draw this diagram with the given numberings. So there can be two conditions. First you have mixing, and then that mixture is sent to the cooling coil. This is condition number one. Second condition is you have the cooling coil. Okay, and then mixing takes place. But in most of the cases, this is the more common condition, wherein first there is mixing that is happening, and then that mixture is sent to the cooling coil, as represented in this case. So has everyone noted down this diagram, this layout?
Yes, sir.
Okay. So next you will open your psychrometric charts, and you will uh, plot these 2 points. That is the point number one, that is the outside condition, and point number two, that is the room condition. Okay, you will plot these 2 points. I have also plotted this question in a psychrometric chart. Over here you have point number one shown. Here is your point number one. And this is point number two. So have you plotted both these points?
Yes, sir.
Yes,
Okay,
sir.
so we'll simply join these 2 points, point number one and point number two. Okay, you join these 2 points. And you will tell me the properties at point number one. Okay, you will have to tell me the values of H1, H2, and HA, and also the specific volume at point number one.
H1 is 89.5.
Okay, that's right. We are getting 90. That's okay.
H2.
That's right.
So can you repeat what did
BS1
you do
is
after
point
joining?
0.9.
What can you repeat what you said?
After joining the points,
After
we
joining
are
1
just
and
measuring the
2,
enthalpy.
yeah, you just tell me the values of enthalpies H1, H2, HA, and specific volume at point 1.
HA 60.
BS1 is point 0.9.
0.9.
Okay, HA, how much you're getting?
60.
Okay, that's okay. So after
59.
finding 5960 is okay. So after finding these values, we can find the mass flow rate of air. That is M1. M1 is your volume flow rate that is given in the question divided by the specific volume at point 1.
Sir, how do we find HA?
HA like this, you have to split this cooling and dehumidification process into two parts. That is your sensible cooling and dehumidification. Okay, here it is I've shown in this diagram where I'm marking.
Okay, sir, got it.
Yeah. How much is the mass flow rate of infiltrated air you're getting?
15.556
Kg per second. Can you tell me in kg per minute?
seconds. Yes. 933.33.
Okay, 933. Okay. So we have got the mass flow rate of the infiltration air. Next, we can find the sensible heat gain due to infiltration. Now, infiltration,
Sir,
yeah,
15.556 is in kg per minute only.
that will be in kg per second, I believe.
No, sir, it is 14 meter cube per minute.
Ah,
sir.
The
so it will be
infiltration
kg
kg
per
per
rate.
minute
minute,
hoga.
no?
15.556. Yes.
Ah,
सर
Fif-
टाइपिंग एरर है यहाँ पे 915 नहीं आएगा 15.556
15.56
ah,
kg per minute.
नहीं यहाँ पे 915 kg per minute. Okay, just a minute.
सर टाइपिंग एरर
हाँ sir. मीटर के per minute है ना infiltration load.
Okay, okay. Okay, so this is a typing error. So how much you're getting? 15.56 kg
56.
per
per
second.
minute.
Yes.
Per
Yeah,
minute.
per minute, yeah.
Per minute.
Yeah.
So next calculation में भी 15.56 लिया है.
Ah, right. So here we can find the sensible heat gain due to infiltration air. So sensible heat gain is given as M1 into H2 minus HA because it is only sensible heat gain. That is why H2 minus HA. So calculate that and tell me how much you're getting. So tell me in terms of watts.
So 2723.
2723. Okay. Uh, I'm getting 2853. So okay, 2723 is also okay. So next we will be finding the latent heat gain due to infiltration air. Okay. Okay. Latent heat gain due to infiltration air is given by M1 into H1 minus HA. we are doing is we are trying to find all the heats that are entering the room. Okay, all the sensible heats and all the latent heats that are entering the room, as well as all the sensible heats and latent heats that are already present in the room, so that we can find the room sensible heat factor.
So it is 8037.267 watt.
Okay, I'm getting 8039. That's okay.
So could you please go to the previous slide once?
Okay.
Okay, sir.
Yeah. So we'll proceed by finding the sensible heats that are already there in the room. Okay. So inside the room, the question says that there are occupants, 25 number of occupants, and per occupant it is around, the sensible heat is around 90 watts. So you'll simply multiply the sensible heat per occupant to the number of occupants, and you should be getting the total heat, sensible heat gain from the occupants.
Yes, sir. 2250.
2250. Same thing you can do for the latent heat gain from the occupants. So you should get around
2625
2625 watts. Okay. So till here everyone is understanding?
Yes, sir.
Okay. So next we'll be finding the total sensible heat gain inside the room. Now the question has given so many heats. So you will have to identify which one comes under the category of sensible heat. Okay. So solar heat gain is sensible heat gain. Okay. You will add to that the sensible heat gain from the infiltrated air that we have just calculated. You will add to that sensible heat gain from the occupants. You will add to that the sensible heat gain from the lighting. And finally, the question also says there is sensible heat gain from other sources. So you'll have to add that as well. And adding all of those numbers, you should be getting around 28
So
point.
what is sensible heat gain due to lightening?
Lighting. Yeah, normal lighting. Normal lights
Oh,
emit
okay.
heat.
Yes, sir. 28.152 kilowatt.
Okay. So is everyone getting total sensible heat as 28.15 kilowatts?
Yes, sir.
So again proceed. Next we'll be finding the total latent heat gain inside the room. Okay. So here the latent heat gain is due to addition of infiltration air, as well as latent heat gain from the occupants. So you should be getting the total as 10.664 kilowatts.
Yes, sir.
Okay. So now you can easily find the room sensible heat factor, which is the ratio of room sensible heat to the room total heat. And that number should be coming around 0.725.
Yes, 0.725.
Now we have to make the RSHF line on our psychrometric chart. So basically there is a sensible heat factor scale on the right hand side. Okay, on the right hand side of your psychrometric chart, there is a sensibility factor scale. So over there you will have to locate 0.725 and you will draw a line from there to the alignment circle. Okay.
Sir, can you please repeat?
Okay. You have found out the RSHF value as 0.725. There is a scale on the right hand side. There is a scale on the right hand side. There you locate 0.725, and from there you will draw a line till your alignment circle.
Yes, sir.
Okay, so in our case, our room condition and alignment circle are coinciding.
Okay.
Okay, so you'll just simply draw that same line till your 100% relative humidity line.
सर अलाइनमेंट सर्कल तो 25 डिग्री पे होता है ना?
हाँ ठीक है,
sir,
कुछ
सर
it is not
अलाइन नहीं हो
coincide.
रहा है.
कुछ साइक्रोमेट्रिक चार्ट्स में 24 पे भी होता है. सो दैट्स ओके. इफ अगर तुम्हारे साइक्रोमेट्रिक चार्ट पे 25 पे है, सो यू विल ड्रॉ a parallel line passing through your room design condition. So parallel line passing through room design condition till the 100% relative humidity line on the left hand side. Okay, इतना हो गया.
Yes, sir.
Next, what you have to do is you have to locate this point of mixing. That is point number 3. This point of mixing over here. So to locate point of mixing, now they have given that how much is the infiltration air being mixed? 40%, right?
40%.
So 60% is our room air that is being mixed. Over here you can see. Just clear all this. Yeah. So over here you can see that this recirculated air is 60%. Okay, and there's outside air that is coming. It is mixing 40%. Okay, so this means that this resultant point number 3 will be closer to the recirculated air condition. Okay, this resultant point number 3 will be closer to the room design condition. So this means that this line 1 to 2, okay, on this line, this length 2 to 3 will be 40% of this total length. Okay, understanding? समझ रहे हैं सबको?
Yes, sir.
Yes, sir.
Because the room air is in a greater quantity, 60%, okay, and outside air is 40%. So the resultant mixing point will be closer to the room design condition. So this length 2 to 1 will, this length 2 to 3 will be equal to 40% of the length 2 to 1. So in your psychrometric chart, you will locate that point number 3.
Sir, around 3.5 centimeter.
So okay. So can you tell me the drivable temperature at point number 3?
28 degree.
28. Okay, that's right. So you have located the line correctly.
28.
Okay. So now this line we have to make. Okay, this GSHF line that I've drawn over here from point number 3. But we don't know where this point number 4 is and where this point number 6 is. Okay. So उसके
DPT
लिए
कितना था? 0.3 का?
कौन सा?
0.3 का?
28. Dry bulb temperature was
Okay.
28.
28.
Yeah. Okay, so we don't know where this point number 4 is, that is I have drawn on this graph. Basically we don't know where this GSHF line will stop on the left hand side. We know the originating point of GSHF line as point number 3 that we have located, but we don't know where this point number 6 and point number 4 will lie. So for that there is only one method. We'll have to use trial and error method for this bypass factor. Okay, so this means that in this formula of bypass factor is given as T4 minus T6 upon T3 minus T6. Okay, so this means that for a bypass factor of value to come as 0.15, for a bypass factor value to come as 0.15, there'll be a one set of values for T4 and T6 which is going to satisfy this condition. Okay, so by trial and error method you should be able to get these values. Okay, so bypass factor is given as T4 minus T6 upon T3 minus T6. We know the value of bypass factor as 0.15. We know the value of T3 that we have just found out as 28. So there will be one set of values for T4 and T6 for which you will get bypass factor as 0.15.
सर कोई रेंज होगा ना जिसमें वो बाईपास पैटर्न पता चलेगा?
Bypass factor is given in the question 0.15.
मतलब सर टेम्परेचर.
हाँ,
सर एक्चुअली
so
क्योंकि
yeah,
इससे पता चलेगा.
I'll tell you. See, this point number 4 and point number 6. See, T6 is always going to be lower as compared to T4. Okay, T6 is always going to be lower as compared to T4. So you'll have to take a starting value for both these things, T4 and T6, and start evaluating. Okay, you can do one thing, just note down these values. You can do that trial and error after your class is over. So as of now, just note down these two values. T4 should come around 10.5 degrees and T6 should come around 7 degrees. So with the help of this, you can draw this GSHF line. So are you able to draw the GSHF line?
सर ट्रायल एंड एरर वालों में समझा कैसे करेंगे उसको? एक ही इक्वेशन मिलेगा.
So yes, so you'll have to just take a starting value of T6 lower as compared to T4 and then start iterating.